I welcome you in my next session 11.2. We are discussing vector value functions. Today we'll going to start the calculus of the vector value function. In calculus, we need the domain. Domain we have already discussed, and then we will define limit, continuity, derivatives, and their applications, as we have done also for one variable. We have done already in some earlier course. We're just going to apply the same things in our for the vector value functions. Now, there was the functions, now they are the vector value function. So we have the vector value function, we want to find the limit, this is 11.2. A vector value function r of t is equal to f of ti plus g of tj and h of tk, where f of t, g of t and h of t are the function of t. And then we took a domain, the t is defined the domain, and domain of r is intersection of domain of f, domain of g and domain of h, and that's the domain of the function r of t. So we have this curve, and we are having here x, y, z coordinate system, as r of t is our vector value function. We say we want to find the limits. This means this is moving to for certain value to L. So if we just discuss it here shortly, that we have done for the vector value function in our previous courses, and that is we have the limit of function f of x, if you remember it. We say limit x tends to a is equal to L, and this is the limit. You know that sometime for the function, and the function is like this x square minus 4 over x minus 2. So when we want to find the value of this function at x equal to 2, the value is of this value does not exist because it's 0.0. But when we want to find the limit, we can find the limit. We say here we can't find the value, but we can find the limit of this function when x tends to the value which making it 0.0, we cancel it, and then we can write just here this is equal to limit x tends to 2, and we expand. This is the factorize this x minus 2 x plus 2 over x minus 2. So our x minus 2 is cancelled x minus 2, and we can write here this is a limit x tends to 2 of x plus 2, we say is 2 plus 2 is equal to 4. So sometime we can't find the value, but we can find the limit. So we can apply the same idea, that we can find the derivative of the vector value function. So we are having three functions, f of t, g of t, h of t. For each of them we have to check the same as we have done here for the function x, that limit exists, limit does not exist. So sometimes limit does not exist. So if the limit of any one of the function does not exist, then means limit does not exist. So I write here the definition of this vector value function. We have the function r of t, the vector value function, is f of t I plus g of t j plus h of t k. I want to find the limit of this function when t tends to a. I say here limit of the function when t tends to a of r of t is equal to limit of the function t tends to a f of t I plus limit of the function t tends to a of g of t j plus limit of the function t tends to a of h of t. Okay. So you can see it, we are taking limit of each of the component and each of the term with the x coordinates, y coordinates, z coordinates. We take the limit of f of t, limit of g of t, limit of h of t. So the limit, all of them must be exist, and we say this limit exist. Which is the limit exists if provided that the limit of the component functions exist. If any one of the limit of the function does not exist, then we say the limit does not exist. We say each of the component function exists, then we say the limit exists. I will explain you with the help of example. I take an example for this purpose. It's my example 1 for today's lecture. It's 11.2. We have an example. I want to find the limit of this function r of t, where r of t is 1 minus ti plus 4 e to power tj plus sine 2 tk. So I want to find the limit when t tends to 0. Here is not t tends to a, but t tends to 0. So I can rewrite this one, and we can write here this is limit t tends to 0 of r of t as I defined above. I take the limit of each of them, t tends to 0, or f of t, that's f of t is 1 minus t, and here is I, plus limit t tends to 0 of 4 e to power t j, plus limit t tends to 0 of sine 2t over t, and I am having here k. So now we can see here this is a polynomial function. We can write immediately the limit of this one. This is 0, we get here I, plus e to power t, the limit is equal to 1, we get 4j. To find the limit of this one, we have to apply the formula sine x upon x. So here we can see here we have sine 2t, and this must be denominator will be 2t. So what we do, we multiply this one by 2 in the denominator and 2 here outside. So now we can apply our formula and we can write the answer of this one, and here is our k. So now this formula gives us sine x upon x, x tends to 0, that is equal to 1. So apply that formula, and we can write here is equal to I plus 4j plus 2k. So you can see here we have the vectorial function, and the limit of this vectorial function is a vector. It's not a scalar, it's a vector. So this was the idea for this one. I take one more example. So I'm having here the function example 2, limit r of t when t tends to 0, where r of t is equal to root of t plus 2i plus t sine 3tj cosine 3tj plus e to power minus 3t k. We take the limit of this one. So limit of this one when r tends to 0 of r of t. So as I did it, we take the limit of the function f of t, t tends to 0, t tends to 0 here, t tends to 0. So we're having here our t tends to 0, and the function here is root of t plus 2i plus here limit t tends to 0, t cosine 3t j plus limit t tends to 0, e to power minus 3t k. We take the limit of this one. Limit of this one t tends to 0, we get here root of 2i plus limit of this one when t is 0, cosine 3t is 1, 0 into 1 is 0, so it's 0j, plus here e to power 3t, e to power 0 is 1, so it's k. So my limit will be 2i, root of 2i plus k. So that's the limit of my function. So idea is that we take, as we have done the limits in case of our earlier course, the function of f(x), we have taken the limits. So we take limit value. Now this with the components, the functions are, we know how to find the limit of that one, the functions. So we just apply that one, and we find the limit of the vectorial function.